so I'm just going to try to do the most succinct introduction to stepper motor as possible while being clear. So let me just try to make this a little more realistic by turning on the camera. Good. Right, so this is just a point and shoot digital camera mounted on top of a stepper motor, and the stepper motor is being controlled by an Arduino motor control shield V2. It is this board here, which is mounted at top an Arduino Uno. I'm not sure how clearly you can see it. Right, so the motor is actually running now. So running the simplest example code that I'm going to show you, which moves the motor at 1 step per second. So it's only 2 lines of code. It's very simple inside a typical Arduino loop right there. So now for the first detail. Stepper motors move a certain number of degrees per step, and they always move in steps, meaning they're designed to move precisely by a certain amount, move a certain distance then, or turn by exactly a certain amount with each step, so that enables you to calculate exactly how much you want to move a motor. So for example, 200 degrees equals 1 full revolution of this motor, or 100 degrees is half a revolution, and 1 step is 1.8 degrees. So that means that this motor moves 1.8 degrees per step. Right, so stepper motors are frequently used to control robots, 3D printers, CNC machines, factory machinery like robotic arms, conveyor belts. There's so many different uses. Of course, computer disk drives, especially floppy drives and optical drives. So they give you control over exactly how much you want to move things. That's the main objective of using a stepper motor. Stepper motors also hold their position. So this motor isn't just throwing the camera. With each step it actually holds, after each step it actually holds its position, which is necessary for accuracy anyway. So yeah, this is just a typical NEMA 17 1 amp stepper motor. Anyway, so for my next example, I'm going to move the camera back and forth, meaning swing the camera around by 70 steps to the left and then another 70 steps to the right. So yeah, on the 4 lines of code. It's actually quite simple to control stepper motors. So do 70 steps forward, and it's single steps, which means that it's just regular steps. So move to do it will do 71.8 degree movements forward, and then when it's done doing those 70 movements, it's going to pause for 500 milliseconds, which is delay 500, and then it's going to step backwards by 70 steps to 71.8 degree steps in the opposite direction, and then it's going to delay again and then restart the loop, and then the cycle continues. So the motor speed is currently set to 10 RPM because I don't want it to move too fast. So I just wanted to show you what this looks like. Yeah, so that sounds a little rough. Stepper motors are like that, unfortunately. And that's also moving a bit fast for a surveillance camera. So one thing you can do is use use micro stepping. Let me just change the setting here. So instead of moving 1.8 degrees per step, it will move a fraction of a step. Micro step. Smoother, not as fast. Yeah, so that's more practical for something like sweeping a surveillance camera. Right, okay. So, right, so, and let's just continue. Now we can also do double steps and interleave steps, but we're not going to cover that in this video. The purpose of this video is just to introduce you to stepper motors, because there is quite a bit you can do with them, and you can manipulate them to a significant extent to get them to do what you need them to do. But just remember that a stepper motor's primary purpose is to make precise calculated movements or calculatable movements. So you can probe the fact that it moves exactly 1.8 degrees per step enables you to write an algorithm that will move a robotic arm to an exact point, exactly to where it's supposed to be, or to move a printer head to the exact point that it's supposed to be, or even to move a piece of paper through a printer reel to the exact spot that it's supposed to be. So that kind of thing plays a major role in achieving precise movements in any robotics application. Stepper motors aren't the only type of motors that can achieve that level of precision. There are servo motors as well, but servo motors, they have their advantages and disadvantages, like the fact that they are able to determine their last position, that kind of thing. And also a disadvantage is they're very expensive. Right, so that's pretty much it for the introduction. Thanks for watching.